This is a pre-calc video from page 90, number 30. We would like to show that this standard form of a quartic polynomial, given r1, r2, r3, r4 as roots, we're showing that the formula for the sum of the roots and the product of the roots will in fact be negative b over a for the sum and e over a for the product. If r1, r2, r3, r4 are the roots of this quartic polynomial, then they will also be the roots of this version where we divided both sides of our equation by a in order to have 1 as our leading coefficient, which will make x minus r sub 1, x minus r sub 2, x minus r sub 3, and x minus r sub 4 the factors of this polynomial. We can then make the equation the polynomial equals the product of the roots multiplied by k, which our leading coefficient is now 1. And so to finish the problem, I need to multiply out all of the factors. This page is devoted solely to that multiplication process, and what I've done here is underlined in blue the first two binomial factors, which gave me this polynomial, multiplied these two, which gave me this polynomial, and then we had a big multiplication party right here. I used a little highlighter to signify my like terms, which all have x cubed, and then some more like terms which all have x squared. These last four like terms all have an x, and then I'll have my x to the fourth and my product of the roots as the first and last term. Now what I want to do is take this back to the first page, and here is my expanded form for the product of these factors, and I'm now setting it equal to the polynomial we started with after dividing by a. We're looking at the corresponding terms. When we look at our x cubed term, I now have an equation which I can make which says that b over a will equal, b over a is the coefficient of this cubic term, negative r1 plus r2 plus r3 plus r4. So that turns into an equation. And I'm also interested in showing that e over a corresponds to the product of the roots. It's true because they are both serving as the constant for this polynomial. This equation needs one more step where I divide both sides by negative 1, and I will in fact show that negative b over a equals the sum of the roots, and e over a equals the product of the roots. And comparing to the formula from our textbook, let's remember that the sum of the roots for any polynomial is the opposite of the coefficient of the second term in descending order over the leading coefficient. The product of the roots is the constant over the leading coefficient for any polynomial of an even degree, and the opposite of the constant over the leading coefficient for any polynomial of an odd degree.